Hello everyone, this is lesson 20. We want to talk about extrema for today and the first derivative test. Okay, so what is extrema? Extrema is, we have two kinds. So one is absolute maximum, or some other textbook indicate the global maximum, and absolute minimum or global minimum. And we have another one, which is relative maximum, or other textbook indicate that local maximum, local minimum, right? So we talk about in this lesson only absolute maximum and absolute minimum, okay? All right, so what is that? Absolute maximum, or same as global maximum, the most largest value of a function, an absolute minimum or global minimum. We indicate just minimum. How about that? Then the most smallest value of the function. Okay, now we have strategy. The derivative is rate of change. We know that, right? So derivative is rate of change. And what else? Derivative, rate of change. And I want to do this one. Okay. We learned rate of speed is the same thing, right? Instantaneous rate of change, instantaneous, tenuous speed, right? What else? We were finding marginal revenue, marginal cost, and marginal profit, right? Yeah. And also finding the slope of a tangent line, right? So we have that for derivative. Okay, now function f is increasing when its derivative is positive. So we had this notation f prime greater than 0 because the derivative is positive, right? So this means the derivative is positive, right? Okay, so I just talked, the derivative is the slope of a tangent line, right? The derivative is slope of the tangent line, right? Yeah, basically just a slope, right? Of the straight line. Okay, then f prime greater than 0 means the slope is positive. So in other words, slope is positive slope, right? Okay, now we say that the function is decreasing when its derivative is negative. And then we denote f prime is less than 0, right? So less than 0 means negative, right? But then f prime is the derivative, right? So this means that, right? Yeah, f prime is less than 0 means the derivative is negative. Make sense? Okay, now I just talked, the derivative is slope of a tangent line. So we have f prime means the slope as well, right? So f prime is greater than 0 means slope is positive or positive slope, right? So f prime is less than 0 means negative slope. Negative slope. Okay, then let's take a look here. This part, we have f prime is greater than 0, right? The derivative is positive, means that f is increasing. And then I said earlier, the positive slope, right? Positive slope. We have a positive slope, right? We have this negative slope. We have this 0 slope, right? Okay, now we have this part. Then f prime is less than 0 means that the derivative is negative, right? And the original function f is decreasing. So we say that this is increasing. The graph goes this way, it's increasing, and then we call this is decreasing. The graph this way is decreasing. F is decreasing. Okay, from here to here, we can say that the derivative is, oh, no, just f of prime is less, greater than 0, right? That means the derivative is positive. The positive means the original function is increasing, right? Increasing, correct? Okay, so I just talked, it's a positive slope, this is a negative slope, it is 0 slope, right? Like with the breakdance, yeah? So positive, negative, 0, positive, negative, 0, positive, negative, 0, yeah? Okay, now look, this is a positive slope, right? Look, this is a negative slope. Everything is negative, yeah? Positive, positive, negative slope. And this is positive slope, right? Okay, now 0 slope. This is 0 slope, right? And this is 0 slope. So 0 slope, how do we express from the derivative, right? So 0 slope, we can express f prime equal to 0. f prime equal to 0. That's the zero slope. So positive slope, we indicate the f, f prime is greater than 0, negative slope, f prime is less than 0, 0 slope, f prime equal to 0. Make sense? Okay, so where is, let's just omit absolute global. So where is the minimum in the case? The most smallest value, right? So here it is, right? This is the minimum. And where's the maximum? Here is maximum, right? So this is maximum. Okay, now, how do you find extrema of function using derivative, right? So extrema, so omit absolute global, and then we say that just simply say minimum or maximum, right? Minimum or maximum. Let me denote it this way. Okay. There's a strategy. Number one, find the first derivative of a function. We know how to find, right? F prime of x. Secondly, critical value. So we never heard the critical value. So how do you find the critical value? So when f prime of x equal to 0. So I introduced you earlier the zero slope. Zero slope means f prime equal to 0. Yeah. So in that case, we say the critical value. So critical value is for x. So we set up f prime of x equal to 0, and or it can be and it can be or f prime is undefined. So when did we hear about the word undefined? Yeah, so when the denominator is 0, right? So undefined means when the denominator is 0. Okay, then in that case, they say that f prime of x is undefined. So we can say that f prime of x, when the denominator is 0, right? So we're looking at the denominator, their denominator is 0. Make sense? So when the denominator is 0, so how about this? F prime of x, yeah? Okay. Step 3, we do evaluate the original function at each critical point and at any endpoints. Think about domain. How do you find the critical point? We set the derivative of x equal to 0 or and f prime is undefined. All right? Okay. Now, the last one, how do we conclude the extrema? So we can find the largest value or smallest value will be maximum and minimum respectively. Okay? All right, let's do this one. Okay, we have a function. So first one, we want to find the first derivative. Step one. What is step one? Okay, so we do derivative. We drop the power, and then we keep the coefficient first, right? And reduce by 1. And we drop the power, reduce by 1. And then third one, keep the coefficient, right? Then last one equal to 0, right? Okay, now second one. Find the critical value. Okay. Oops. Step 2. Critical value, how do we find the critical value? We set f prime of x equal to 0, right? Or f prime of x undefined. Let's take a look. There is no fraction, right? So we can ignore the second part. Oops. I'm doing this one. Okay, so ignore. There is no. How about that? There is no. All right, so we have f of prime of x. Okay, that's not the one. All right, so let me write down. So f of prime of x equal to, oh, I did not simplify. So there will be x squared minus 2x minus 3, right? So x squared minus 2x minus 3, we set equal to 0, right? Okay, we had to experience how to factor out and then how to find the 4 x values, right? Okay, so can you please think about how to factor? So there will be x minus 3, x plus 1. Let's check the answer. Check it out. So we have, this is negative 3x. This is a positive 1x, which is negative 2x. We get the middle term, negative 2x, yeah? Okay, so that is the right answer. Then by zero product property, we have x minus 3 equal to 0, x plus 1 equal to 0. So x equal to 3, x equal to negative 1. Ooh. Okay, just write down. So those are critical value. All right. Another page. Step 3, right? Copy. So we need to evaluate the original function at each critical point and at any endpoints, right? So let's take a look. We have a critical point. This is step 3. So critical points, critical values, x equal to 3, x equal to -1, and endpoints, think about the domain. So this will be here. Can you see that? Copy. X is between -2 and 5. So that will be endpoints. Come on, come on, come on, move. All right, so we're gonna evaluate 4 numbers there. So let's do smallest number first. So how about this? F of -2. Now I need the original function because I said f of, right? Not the f prime of. So original function. I need to erase this one. Oh, this is not. Here is original. There is the one, right? Copy. Okay, so let me see. So f of -2, 1/3, -2 to the third, minus -2 to the second power, minus 3, -2, plus 2. Okay, so that will be 4/3, which is approximately 1.33. Okay, now I just want to copy, rewrite, copy, paste. Okay, the second smallest one is -1. So there will be -1, -1, -1, -1. Yeah. -1, -1, -1, -1. Then we get 11/3, which is a 3.67. Okay, how about next smallest one is 3, right? 3, 3, 3, 3. So we get -7, f of 5. Oops. Copy and paste. Five, 5, 5, 5, 5, 5, 5, 5. Then We have, oh, same 11 over 3. So this is a 3.67. Okay, so which one the most largest one? We're looking at the number from here. Okay, so this is the most largest one, right? It can be, okay, it can be pi, right? It's not always unique. Unique means there is only one, right? It can be 2, it can be 3, it can be 4. Yeah, it depends on. So this is a maximum. Also, this is a maximum. And which one is the smallest value? That is the one, negative 7, right? So this is the minimum. Okay, so we can conclude F has a 2 maximums. (11/3) at x equal to -1 and x equal to +5, right? Or we can say that maximum at, we can express maximum at f of -1 equal to 3.67 and f of 5 equal to 3.67, right? Okay, now minimum at f of minimum 3 equal to -7. Or we can say that f has minimum of -7 at x equal to 3, right? Okay, how about the graph? Let's take a look. Graph is here, right? Oh, it's already there, right? Okay, so maximum, 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 right? And minimum. Okay, and we can see that this is a critical point, critical values, right? So f prime of x equal to 0, right? Critical values. And f prime of x equal to 0, critical values. All right, now, business example, average cost. So suppose the average cost of a mining operation depends on the number of machines used, and average cost in dollars are given by there, where X is the number of machines used. How many machines give a minimum average cost? And then what is the minimum average cost? Yeah. Okay, so how many machines? So we want to find out what is X. Right, so means Okay, so we are finding basically the critical values. Means find the critical value. All right. Okay, let's do it. How to find the critical value? Let's make this A part. This is a B part. A. We want a derivative, right? So the average cost and then we want a derivative C prime of X. Okay, first term, we keep the coefficient. That's it. And second term, oh, we have to convert 20,000 plus 1,278,900 X to the negative 1. Yeah? Okay. Then second term, we drop the power. And reduce by 1. So that will be a 900 X to the negative 2, right? Okay. Now, critical value, we set the derivative equal to 0, right? Oh, not this one. C prime of X equal to 0. So we have 2000 minus 278,900 over X squared equal to 0, right? Okay, we need to solve for X. Okay, first of all, we need to get rid of the neighbor term first. So subtract this one, both sides. So we have negative over X squared equal to negative 2000, right? Okay, we times X squared, both sides. So we have negative equal to negative 20 X squared, 2900, right? We divide by negative 2900 both sides. So we have this number is a 441 missing negative equal to X squared. So we take the square root both sides. Then other side is plus minus. But we talk about the machine. We cannot have a negative machine, right? So we take the only positive. So that will be X equal to positive 21. That's the critical value. That is the how many? 21 machine, right? Okay, so by the way, why we need that? because we had earlier, right? So we have to have a flat of derivative, right? That means 21, we can see from the graph, right? Easily. So there is red. So let me write down here. That is, there is a flat, which is C prime of x equal to 0. You guys okay with this? That's why we need the critical values there. All right, in that case, x equal to 21, right? So that part is 21. Okay, second part, what is the minimum average cost? Okay, we plug in, we substitute when x equal to 21. I don't have a space. Let me write down. What is the minimum average cost? Copy. So we found earlier, I cannot erase. So this means when x equal to 21, what is C over 21, right? The average cost. So let me, the function, okay. So we have C of 21 equal to 2900 x plus 1,278,900 over x, which is 21. Then if we calculate this one, we get $121,800. So this is dollars per machine. Okay, so we just had that, the graph. Well, how much was it? 100, 100, 121,800, 121. So there will be, and this is when x equal to 21, we have, this is $121,800. Yeah, it's okay? Okay, so let's try this one. A firm can produce only 1,600 units per month. The monthly total cost is given by that, where X is the number produced. If total revenue is given by that, dollars, how many terms X should the firm produce for maximum profit? Okay, in that case, it's maximum we need to look for. All right, so how do you find the profit function? Profit. Oh, you can answer. Yeah. So profit function. Oh, so let me denote this way. P equal to R minus C, right? So revenue minus cost function, right? So profit function equal to revenue minus cost. So that is a P over X equal to R over X minus C over X. Yeah. So P over X, we have that. Oh, that's R over X. Yeah, sorry. Yeah, should be R over X. Okay. And the cost function, be careful, we have to subtract everything, cost function. There will be that. Okay. We do algebraic work. So there will be minus the x squared, right? So we have x squared negative 1 over 100 x squared and 250. So if we simplify, then 250x minus 1 over 100 x squared minus 300 minus 200x, yeah? So we have 250x minus 200x, which is 50x positive and negative 300, right? Okay, so maximum profit, we have to find out, same process, looking at the critical value. So step 1, find P prime of X. Step 2, find critical value. Step 3, evaluate critical value and the endpoint. Then step 4, determine the maximum and minimum, right? So in that case, we need to look for only maximum, right? Okay. So let's find out step 1. P prime of X. Okay. So we keep the coefficient negative 1 over 100, drop the power times 2, x. Second term, we have a positive 50, right? And third term is 0. So we have 2 goes to 150 times. So we have negative 1 over 50x plus 50. Okay, so critical value. So set P prime of X equal to 0 or and P prime is undefined. But in that case, there is no, right? because there is no fraction. Okay, so we set p prime of x equal to 0. So there will be negative 1 over 50x plus 50 equal to 0. Solve for x. So we move to constant term, other side. So subtract 50. So we have negative 50. Okay, now solve for x times negative 50 both sides. So we have x equal to 2500, right? Okay. 2500. So let's take a look here. We have a firm can produce only 1600 units per month. This means the x value must be between 0 to 1600, right? So we said that this is a domain, right? And moreover, we said a feasible domain. Feasible domain. Okay, but then critical value, let's take a look. Critical value, which is 2500, right? But the company cannot produce more than 1600, right? So this is too large. So we can't, company cannot produce, right? Since the firm produce only um, not more than, no more than six, no more than 1600. So we cannot use that. Okay, then step 3 said evaluate the endpoints. Endpoints is between 0 and 1600 is the endpoint. So step 3, I need to copy. I need to. Copy. Okay, so critical value x equal to 2500, we can use. So we have endpoint. Is x is between 0 and 1600. So let's using that, right? So what is the function? The original function, which is the profit function. So we will have this one. So we have a profit function. So P of 0, negative 1 over 100, 0, and plus 50, 0, minus 300, which is negative 300, right? P of 1600, So let me copy. So 1600, right? 1600. Okay, this one we get 54,100. This is money, right? So it can be negative money, right? Losing money and positive. Okay, so step 4, we need to determine maximum and minimum. But in that case, only maximum profit, right? They said that earlier. Come on. So maximum profit here, maximum profit, they ask us. So this is a maximum. So 54,100 at production level of 1600 units. So 1600, right? So let me copy here. 1600. And then how much was it? Bad memory. Hold on. Oops. I cannot go. 54,100. 54,100. Okay? Okay, one more. All right. So this one, same strategy. If the total cost function is that dollars producing how many units X will result in minimum average cost per unit. Okay. Let me copy everything. Step 1. Okay. So minimum here, right? So in the case of C prime, step 1. So we have the function and C prime. Hold on 1 second. Okay, so before we find the derivative of a cost function, so there is no bar, right? Can you see that? The average cost must be has the bar here, right? This is just the cost function. So how do you find average cost function from the cost function? Do you remember from the previously? This is a cost function. We want to know about the average cost. Oops, I cannot do. Okay, so we denote this way, right? So then C over X over X. Do you remember? Okay, then we have 810 plus 0.1 X squared all over X. That will be 810 over X plus 0.1 X, yeah? Okay, now let's simplify. Okay, that will be, we need to convert to the power better in order to derivative. So 810 x to the negative 1 power 0.1 x, yeah? Okay, derivative of average cost function, that will be 810 and drop the power and x and negative 1, right? So it's negative 2. And second term, just a coefficient. Okay, rewrite negative 810 x squared plus 0.1. Step 2, we need to find the critical value. So we set average cost function prime x equal to 0. So that is negative 810 over x squared plus 0.1 equal to 0. And we need to solve for x. Okay, so we subtract 0.1 both sides. So we have a negative 810 over x squared equal to negative 0.1. Okay. Multiply x squared both sides. So we have a negative 810 equal to negative 0.1 x squared. Okay, now we divide by negative 0.1 both sides. So x squared equal to, we have 8100. So we take the square root of both sides. So other side plus minus 1. Once again, the x equal to, in that case, the how many units? So number of units, right? So we cannot have a negative units. So x equal to 90. This is a critical value. Step 3. They don't give us the endpoints, right? So step 3, we need to evaluate the critical value and endpoints. Copy. So no given. So we don't have that. So we do evaluate only the critical value. Then we need the average cost function. Okay. I need to copy this one. That's for derivative. Okay. So that is average cost function. So we have a critical value, which is x equal to 90. So C of average cost function, we substitute 90. Then 18 over 90 plus 0.1, 90. Oh, let me see. Let me calculate it one more time. Yeah, that is correct. So yeah, so 90. So we get, this is 18. Okay, so there is a cost function. Average cost is 18 per item, right? And 90, right? So 90 units and 18. Make sense? Okay, any question? So we're done, right? So let me double check. Okay, so we finished. Thank you for watching. Bye.